Footnote: solid angle. The angle subtended by any line at any given point is expressed in radian. Similarly, any given surface forms an angle in 3 dimensions at any given point. To understand such an angle, let us consider a surface element vector ds with a position vector r. The solid angle d omega extended by such a surface element at point O can be defined as d omega is equal to projection of vector ds normal to vector r upon r square. That is equal to vector ds dot r cat vector upon r square. That is equal to ds cos alpha upon r square. The unit of solid angle is steradian. Gauss's theorem. The total electric flux passing through any closed surface is the ratio of the total electric charge enclosed by that surface and epsilon 0. Proof: consider any given surface enclosing the charge Qi. Remember that there is no charge on such a surface and it should not be. Otherwise, the electric field will be infinite at the point where this charge is placed. This kind of surface is called the Gaussian surface. Suppose the electric vector and the surface element are represented by vector Ej and vector Daj respectively at point A on the given surface. The flux passing through this surface is d phi j is equal to vector Ej dot d vector Aj is equal to modulus of Ej into modulus of d vector Aj into cos theta. But modulus of vector Ej is equal to k into Qi upon Rj square. That is equal to 1 upon 4 pi epsilon 0 into Qi upon Rj square. Therefore, d phi j is equal to 1 upon 4 pi epsilon 0 into Qi upon Rj square into Daj cos theta. Moreover, Daj upon Rj square dot cos theta is equal to d omega j, where d omega j is the solid angle subtended by surface element Daj at charge Qj. In using equation we get, and taking the summation to obtain the total flux, phi is equal to summation j of d phi j is equal to Qi upon 4 pi epsilon 0 into summation j d omega j. Writing this summation for the microscopic surface elements in the integral form, phi is equal to integral d phi is equal to Qi upon 4 pi epsilon 0 into integral d omega. But integral d omega is equal to 4 pi. Therefore, phi is equal to Qi upon epsilon 0 or phi is equal to integral a vector E dot vector dA, that is equal to Qi upon epsilon 0. If many electric charges such as Q1, Q2 and so on are enclosed by some surface according to the principle of superposition, we get the field vector E equal to vector E1 plus vector E2 and so on. Here, vector E1, vector E2 and so on are the fields due to electric charges Q1, Q2 and so on respectively. In such a condition, vector E is equal to vector E1 plus vector E2 and so on, and we shall get Q is equal to Q1 plus Q2 plus and so on the right hand side. Therefore, integral A vector E dot vector dA is equal to Q upon epsilon 0. If the charge enclosed by a closed surface is continuously distributed, then integral vector E dot vector dA is equal to 1 upon epsilon 0 into integral rho of vector R dV. In figure, the surface S encloses the charge Q, while the surface S0 does not enclose any electric charge. Let us consider that these two surfaces are connected by a fine tube as shown in the figure. Now taking the surface integral over the entire surface shown in the figure, therefore integral S vector E into vector dA plus integral S dash vector E into vector dA plus integral S0 vector E into vector dA is equal to Q upon epsilon 0. If the tube connecting two surfaces S and S0 is narrowed to 0, the surface S will be the closed surface in the limit finally, and integral S vector E into vector dA is equal to Q upon epsilon 0. As the connecting tube is narrowed to 0, integral S dash vector E into vector dA is equal to 0. In such a case, in equation integral S0 vector E into vector dA is equal to 0. If the resultant charge enclosed by a closed surface is 0, then integral vector E into vector dA is equal to 0. This can be explained with the help of the following simple illustration.